For this question, we're going to use the formula for slope to determine the average rate of change between given moments in time. So over here, we have a graph that tells us how far a car has traveled on a straight road. So like at time equals 0, it's 0 feet from a given point. And then over here at 30 seconds, it looks like the car has traveled a total of 300 feet from a given point. So let's look at part A. What was the average velocity of the car from t equals 0 to t equals 30 seconds? So that is from here to here. The way you can visualize this is by drawing a line that connects the 2 points and then finding the slope of that line using this formula. That will be the average rate of change between those 2 points. Let's see why. For starters, when t is equal to 0, I can look at the graph and see that the car has traveled a total of 0 feet. So that actually gives us a point. That's the point 0, 0. So it'll act as one of our points. For the other point, that's when t is equal to 30 seconds. So for t, I get 30, and then the distance it traveled was 300 feet. So I have 2 points. I can put this information into the formula for slope, and it's going to tell me the average rate of change. All right, so this is for part A. So the slope, it's going to be the difference in the y values, so that's 300 minus 0. But I'm going to be a little bit more explicit here. I'm going to put the units after it. It's really 300 feet minus 0 feet. And this is divided by time, so it's going to be 30 minus 0, but really that is 30 seconds minus 0 seconds. I'm including the units here because when I subtract the top, you get 300, but that's feet. If you subtract the denominators, that's 30, which is seconds. 30 goes into 300 10 times, but you have units that are left over. The units are feet per second. So I'm going to write that as a fraction, feet per second. So the reason the slope is called average rate of change is because the units that you end up with is, in this case, a velocity. It's a speed. So it's what we've done before, but I've just attached the units on the end. For the remaining parts, since I know the units are always going to be in feet per second, I will leave them off in this process and just put them on at the end. But this is the answer for part A. The average velocity from t equals 0 to t equals 30 seconds is 10 feet per second. Okay, let's check out part B. So we'll move on to that part next. So for part B, same idea. I now want the average velocity from 10 to 30 seconds. So now I'm looking here to here. And I'm going to do this directly using the slope formula. I'm going to list my 2 points first. So when t is equal to 10 seconds, we have the point 10, 100. So that is at 10 seconds, the car's traveled 100 feet. For t equals 30 seconds, so again, we already know that point, it's 30, 300. When I look at the formula for slope, I get, all right, the difference of the y's is going to be 300 minus 100. The difference of the x's is 30 minus 10. When I take this expression and simplify it, I get 200 over 20. This reduces down to 10 as well, but I know the units are going to be feet per second. It's actually the same thing as part A. The average rate of change from 0 to 30 seconds was 10 feet per second, and the average rate of change from 10 to 30 seconds was also 10 feet per second. That makes sense. If you draw a line that goes between this point and this point, the slope of that line is actually equal to what you get if you draw a line going between this point and this point. So visually, it makes sense as well. Okay, if we look at part C, this is definitely different than parts A and B, and the reason is because A and B are asking for an average speed, but C is not. It's actually asking for something that happens at exactly 1 point. So for part C, it first asks, how fast is the car traveling at exactly t equals 10 seconds? So that's right here. So it's not giving us two different points to work with that we can draw a line between. This is where we would use the idea of a tangent line. I think the best we can do is approximate what we think the answer is. So we might get, you might get a different answer than me depending on how you try to draw this. But what I'm going to do is go to this point, I'm going to draw in a tangent line and see if I can reason out what the slope of that line is. It's not going to be perfect because we don't have an equation, we just have a graph that we're working with. So I visualize the tangent line as looking like this. And actually, I'm also noticing that the slope of that line is pretty close to the slope of this line. And I'm going to choose to use the green line just because it goes through a couple of points that I can refer to. So my thought process here was I first drew a tangent line, and then I noticed, well, I need some points that are nice that I have to refer to if I want to figure out the slope of this line. So I just kind of like shifted it up a little bit, and I got this thing. So to figure out the slope of this line, I'm going to use this point and this point. Okay, so it appears that this is the point maybe 5, 50. Again, I'm just sort of approximating this. So at 5 seconds, the car has traveled a total of 50 feet. And then we also have at 15 seconds, the car has traveled 200 feet. So that is going to be 15, 200. The rest is now using our slope formula to get the slope of this line. So it's going to be 200 minus 50 divided by 15 minus 5. If I subtract those, I get 150 over 10. If I divide those two numbers, I get 15. And like before, I know the units are going to be feet in the numerator, seconds in the denominator. The reason that slope gives you a velocity is because we have units of feet per second. So the slope of this tangent line was equal to the slope of this line. So at exactly 10 seconds, it looks like the car is traveling this fast. All right, so let's try this again. It says now, look at t is equal to 20 seconds. So again, we're just kind of like trying to approximate it. We're trying to get a reasonable answer. So here's 20 seconds. It looks like the graph kind of continues a little bit, and then it starts to like drop off here. So if I try to draw a tangent line at this point, I actually think we get a horizontal line. Like at this instant, like we're moving on this equation, the tangent line appears to be horizontal. So this is just sort of my educated guess. But if I draw a tangent line at this point, it looks like it's a horizontal line. Now, I think I'll use the formula for slope to figure out what this slope is, but I know a horizontal line has slope 0. But just to use the process that we were doing in the first part here for 10 seconds, I'm going to use as one of my points, here's 20 seconds, 200 feet. So that's 20 seconds, 200 feet. And then another reference point appears to be 25 seconds, 200 feet as well. So that's going to be 25, 200. If I put this into the formula for slope, I have the difference of my y values divided by the difference of my x values. And the numerator is 0, the denominator is 5. This reduces down to 0. That's 0 feet per second. So, that makes sense. The graph is somewhat horizontal here, so it looks like, the car was driving, it's moving along the straight road, and then for a few seconds, it like came to a stop, and then it waited. And at this moment, the velocity was 0 feet per second. And the last thing for part C was, what about at t is equal to 30 seconds? Like what happens there? Again, I'm going to try my best to, draw in a tangent line and get an approximation. So our answers could vary, depending on how you're looking at this. But here we have, 30 seconds. If I try to draw a tangent line, like, maybe I get something like this. It's definitely not perfect, but here's my tangent line. And here, I have a point on the tangent line that appears to be the point 30, 300. But I need a second point to work with that falls on this line. I mean, you make it something than me, but I'm going to use this point here. This is the point. I mean, the value for time. Okay, let's see. This is 25 and this is 30, and it looks like maybe we're halfway in between. It's just a guess. It looks like maybe that's 27.5, and the y value would be 0. So, using those points to get the value of the velocity, I'm going to take a difference of the y values. I'll do 300 minus 0. This is divided by the corresponding time values, which is 30 minus 27.5. So that's going to be 300 divided by 2.5. So that's going to be half times, let's see, let's get out a calculator just to make sure I get the right value here. Okay, that is 120. And the units are going to be feet per second. A rough approximation, certainly not perfect, but we're just estimating it. Okay, there are a couple of final parts to this problem. If we look at part D, it asks, what does the horizontal part of the graph between 15 and 20 seconds mean? I think I addressed this earlier, but this tells you how far your car is away from a given spot on a straight road. And then between 15 and 20 seconds, the car didn't move. It stayed put. It didn't travel further away. So that would be a reasonable answer. But another way you could state this is, well, it looks like the speed or the velocity is 0. So the car is not moving. I know the slope is going to be 0. So this is the velocity of the car. It's going to be 0 feet per second. It's not moving. And lastly, part E asks, what does the negative velocity at t equals 25 seconds represent? Which is right here. So negative velocity, what does that mean? Like if you draw a tangent line, so we're not looking for an approximate value. I don't care what the number is. This part is just stating that if you draw a tangent line to this point, which maybe I'll sketch that on here with a green line. So here I'm just doing my best to draw a tangent line. The slope for that point is going to be a negative number. Negative something, who knows? But what does that tell you? What does that represent here? I think what it represents is, so there's this fixed point where your car starts from, and then it starts moving along this straight road in this direction. So it's moving further and further away. Eventually it gets to a spot where it kind of just stops, and then the velocity becomes negative. I believe what that means is the car then switches directions and goes in the other direction for a little bit. So from here to here, I know that the car is getting closer to the point that it started with, so it means it's moving in the opposite direction.